one of the objectives of the new generation of Eurocodes has been to include provisions for the assessment of existing structures. In this presentation, we will start commenting very briefly some differences between assessment and design, and then we will comment some topics that could be conditioning factors in the assessment of concrete structures. Regarding the first point, or the first part, Eurocode 0 has been divided into two parts. Part one is like the current code we have, focus on design, but for the second part, it gives some provisions for the assessment of existing structures. Regarding the second part of the presentation, as Mr. Gant has already commented, Eurocode 2 has included an Annex I, with provisions for these topics. Starting with Eurocode 0, as it is indicated in the introduction of Part 2, the Part 1 can also be applied for existing structures, but with additional provisions which are given in Part 2. These provisions are rules for the assessment of structure in case of intervention, and also for using update data in the basic variables. In this example, we can check some differences between assessment and design. The slide shows a plan of a bridge, which was built in the 1930s, and a view of the bridge today. Of course, the regulatory criteria in design were different to those we have today, and of course, many specifications about materials or details will not be met today. On the other hand, the bridge allows to have information directly from the structures, and it reduces the uncertainties, and that will allow to reduce the reliability index. In the same way, in cases like this, where the bridge have developed an adequate behavior, survival, mainly when permanent loads are dominant, allows to reduce the reliability to consider in the new service line. In the same way, in existing structure, the measures to increase security are the cost is much higher than in the design. So that is another reason why we could reduce the reliability index. In any case, we engineers must be sure that the validity of the physical models we use as concepts, as utility or robustness, were not as important as they are today. Because all of this, Part 2 of Eurocode 0 has included provisions for the investigation of the existing structure, but also some criteria to make the assessment. And in the case we do in a semi-probabilistic approach, as we do in design, it is proposed to do it with a different probability index, different to 3.5, 3.8. This means that usually partial factors are lower than we use in design, but we must be careful, as we will check now. Going into concrete existing structures, one of the main topics we need is to specify the concrete class. And we do it taking course, we should do it extracting course from the structure. When we have the concrete class, we can define the design, or in this case, assessment concrete strength, by dividing the concrete class with a partial factor. For the first step, Annex I has included an important coefficient which takes into account the damage because of core extracting, the uncertainties of testing, and also the differences between concrete inside and concrete in the structure, as Jose Maria commented before. For the second step, as Jose Maria already commented, it is possible to actualize the partial factor, taking into account the new reliability index, but also the scattering and the size of the sample, of course. This scattering is very important. In this graph is represented the coefficient of variation of concrete in different buildings and structures we have studied. And as you can check, in most cases, it is over 0.20. Using the formulas that you can see in Annex A, you can easily obtain this graph, and you will check that the partial factor for a reliability index of 3.8 will be higher than 1.5 we use in design because of that scattering in the sample. Of course, if the size of the sample is smaller, the differences will be higher. On the other hand, we can usually use lower reliability index, and this allows that the differences with design partial factors are lower. Another key issue in the assessment of concrete existing structures is shear in elements without shear reinforcement. As it will be explained later, Eurocode 2 has adopted the critical shear crack theory, and in the main test, they have done a small simplification to have a formula, a simplest formula. In the annex, the original formula is proposed, but in both cases, the important thing is that you can use the strain in the longitudinal reinforcement at control section, epsilon v, and that allows to optimize the capacity under shear. It is explained in the paper of the monographic, but very briefly in these graphs you can check in thin lines the differences between the two formulas, Annex I and the main text, are not very high, but in both cases the capacity of shear is quite bigger than with the current code. Maybe one of the most controversial points in the Eurocode is anchorage. And this is a very important issue for existing structures of concrete, because as you know, in ancient structures, it was very common the use of plain bars anchored by hooks. And in addition to that, the covers of the reinforcement were quite low. Annex I has modified the formula that it will be explained later this afternoon, based on tests over plain bars, and the result is what is shown in this graph. If we compare the anchor length obtained with this formula and the anchor length obtained with ancient model code 90, because last model code doesn't include provisions for plain bars. For example, in a very common situation of a bar 20 millimeters of diameter, and with these conditions, the length which result is more than the double that with model code 90. If we use ancient codes of Spain, differences are even higher. Finally, I can finish without mentioning durability. Mari Carmen has already said something, but one of the key questions of the assessment of a existing structure is to answer which is the residual service life. Regarding this point, Eurocode 2 has not predictive methods. And as a difference with ultimate limited states, a consensus with the property or with each part intervening in the project must be required. For example, in a very common situation where the carbonation front of the concrete has reached the position of reinforcement, in some cases, it is necessary to paint all the structure, even to repair many of the surfaces. But in other cases, it can be left without doing anything if the speed of corrosion is low enough. Annex I also has included some provisions for the calculation in ultimate states of the deteriorated structures, both for the concrete, the cross-section of concrete, and for the reinforcement. And finally, some conclusions. First, the future Euro code will standardize at a European level methods for the assessment of existing structures. These new frameworks are a great step forward, since it will be one of the first international design codes to specifically address assessment. However, the proper application of this type of assessment requires knowledge of the historical context within each country with respect to prior building codes and construction practice. And finally, there is still a long way to go, including aspects such as the treatment of deteriorated or damaged structures, the definition of predictive methods for estimation of degradation processes, the consideration of the level of knowledge in the assessment, etc., that need to be further analyzed for the practical implementation. Thank you very much for your attention.